Good morning, sunshines. It's Fowler again. So here is today's lesson on triangles. We are going to be looking at the mid segment of a triangle. So mid definitely means like middle. Segment means line. So we're looking at the middle line of our triangle. So a mid segment is formed by connecting the midpoints of two sides of the triangle. It makes two things happen. One, it makes the third side parallel to the one below it. And two, the little is twice the length of the big. So I'm gonna go to the notes, we're gonna look at that, and then I'll give you guys your assignment for today, and then your exit ticket as well. So here are the notes for today. I'll attach a PDF. You guys should look at it as a PDF if you want to download it. If not, just take some notes on a scrap sheet of paper. You don't have to turn notes into me. I trust that you guys would use the notes because the notes come in a lot of handy when you guys are doing the practice. And when I give you guys the assessment on this, that will also help as well. So, mid-segment of a triangle. Mid being middle, segment being line. This guy right here from D to F is the mid-segment. Okay, a mid-segment of a triangle is a segment connecting the midpoints of two sides of the triangle. So for this guy, that part's congruent to that part. So D is the midpoint. And for E is the midpoint of this side because that's two equal parts. Midpoint splits it into equal parts. So in our example, DE is the midsegment. Okay, so the triangle midsegment theorem states that if it is the midsegment, okay, so the midpoints of two sides are joined by a segment, then the segment is parallel to the third. So this guy is parallel to this guy, okay? Parallel does not mean they're the same length. Parallel just means they have the same slope, they go in the same direction, and they never intersect. Parallel lines can also give us angles, by the way. And so it's parallel to the third side, and it is half as long. So if this was 10, our mid-segment will be half that, which is 5. Okay? So it says, using the diagram above, if DE is the midsegment, then DE is parallel to AC, and 2 times the length of DE equals the length of AC. Okay? Twice the little equals the big. That's what you have to memorize for this. So twice the little equals the big. Okay, so I'm gonna do these problems with you right here, and maybe a couple more examples, and that'll be it for the day. So, all pairs of parallel segments. If you guys notice that X is the midpoint of this side, Y is the midpoint of this side, and W is the midpoint of that side. So we have 3 different mid-segments here, and it wants us to identify the parallel parts. Well, because we have 3 different mid-segments, we're gonna have 3 different pairs of parallel lines or segments. So I like to start, let's go start with this guy. And I'm gonna trace the ones that I start with. So XW is parallel, okay? So which segment on our other triangle is it parallel to? Well, it's parallel to this one right here. RS. Okay, now I'm gonna do the top one. Let's go, actually, let's do this one. WY is parallel, so something having the same slope would be this one. To QR. Notice I started left to right, WY, QR, when I wrote that. Up to down, XW, RS. Okay? Be consistent with how you name these. And the last one, let's go XY is parallel. Okay, XY is right there. So top to bottom, QS. Okay, so just naming the parallel sides. That was the first problem. Okay, the next one, 3. If L, M, N, and P are midpoints, okay, of the sides of triangle P, Q, R, and then it tells us PR is 46, PQ is 40, and LN is 17. Okay, so I want to label what I know. So P to R is 46. P to Q is 40. And L to N is 17. So let's see, L to M. L to M is right here. Okay, and that is a mid-segment because we know they're all midpoints. Okay, so that's the little, so twice the little equals the big. Okay, so 2 times ln equals 46. So we're going to take that 46 and divide by 2. And so LM, should be 23. Okay, the next one, MN. MN is right here. Okay, it's parallel to QP. Okay, so twice the little equals the big. So we'll take our big, 40, and divide by 2. To get that is 20. Okay, next one, Q to R is right there. Okay, Q to R is parallel to this 17 over here, the LN. So twice the little equals the big. So we're going to take 17 and times by 2. And 17 times 2 is 34. And the last one was to know MR. Well, MR is right here. Okay, MR is from the midpoint to the side of this whole segment. So we'll take that 32 and divide it by 2 because it's half the segment and get 17. Okay, twice the little equals the big. All right, and example 5. All right, so we've got 2 congruent parts, so that's midpoint. 2 congruent parts, so that's midpoint. So we've got the mid segment. So we have this rule, twice the little equals the big. Okay, so 2 times 7x is 14x equals our 17x minus 18. All right, so we want to get the x's on one side, so there's only an x here, so we gotta leave them here. So let's subtract the 17x over. Okay, 14x take away 17x is a negative 3x equals a negative 18. Divide by the negative 3. And x equals positive 6. Twice the little equals the big. And let's just do one more example. We're going to do 6 together right here. Okay, so 6, let's see. We've got a midpoint here and a midpoint there. So we definitely have a mid-segment. So when we set this up, twice the little equals the big. All right, so I want to distribute this too. So we've got 12x plus 62 equals 19x minus 36. Okay, so we got x's on both sides, constants on both sides. So I want to move the smaller x over. And so the 62 has to stay. That means the 36 has got to go. So 62 plus 36 is 98. And 19x take away 12x leaves us with 7x. Okay, and so we're going to do 98 divided by 7 and get 14. Okay, main points today. Twice the little equals the big. All right, guys, you have an IX on this and an exit ticket. And then I will see you tomorrow. Remember, we are going to be doing a Zoom tomorrow at 1 p.m. Be there or be square guests. Let me know if you guys can't make it. And we'll see how it goes. All right, bye.